Welcome to another deep dive. Today we're going to be looking back at the 1870s
Ooh,
at a scientific mystery
okay.
that's been called Airy's failure.
Oh, interesting.
And no, it's not about a flubbed piano recital or anything like that.
Right. So
Um,
this Aries failure
yeah.
is actually an experiment that was trying to prove
Okay.
that the Earth moves around the sun
Oh,
using a water-filled telescope.
the water-filled telescope. Okay, I'm already intrigued.
Yeah.
Now, the sources that you sent me, a YouTube video and its transcript, mentions something called stellar aberration being like kind of at the heart of this.
Yeah.
Can you break that down for us?
So imagine you're walking in the rain,
Okay.
and even if the rain's falling straight down,
Uh-huh.
it appears to be coming at you at an angle
Right.
because you're moving.
Right.
The faster you walk,
Yeah.
the steeper that angle appears.
Okay.
Stellar aberration is basically the same idea, but with light from stars.
So because the Earth is zipping around the sun, the starlight should seem to be like hitting us at an angle too.
Precisely. And in fact, astronomers have to adjust their telescopes a little bit to compensate for this effect.
Huh. Okay.
Now, picture this
Yeah.
George Bedell Airy,
Okay.
famous astronomer.
Mm-hmm.
He had this thought. What if he thought we slow down the light even further
Okay.
by making it travel through water?
Aha. So that's where the water-filled telescope comes in.
Exactly.
Okay.
So he figures if the Earth really is moving
Yeah.
and we make the light move slower through the water,
Mm-hmm.
that angle of aberration
Oh.
should get even bigger.
Oh, okay.
So he expected to have to tilt the telescope even more
Right.
to see the star correctly.
So what happened? Did you have to tilt it more?
That's the mystery.
Mm.
When Airy actually conducted the experiment, the angle of aberration
Yeah.
didn't change at all.
Wait, so that means the Earth wasn't moving.
It certainly raises that question, doesn't it?
I mean, okay, so I see why it's called Airy's failure. But that can't be right, can it? Like, I mean, we know that the Earth revolves around the sun.
Well, that is the big question, isn't it? This
Yeah.
threw a wrench into the whole accepted understanding at the time, and it continues to spark debate today.
Yeah, this is where it gets really interesting.
Yeah.
The YouTube video that you shared featured some pretty heated discussion about this experiment. Can you walk us through some of the main arguments that are being thrown around?
Yeah, you can really see two camps forming in the video.
Okay.
On the one hand,
Mm-hmm.
you have people who argue that this is proof that the Earth isn't moving.
Whoa, hold up. Are they saying that the Earth is flat?
Not necessarily.
Wow.
Some people who believe that
Okay.
suggest that the results of Airy's experiment could be explained by something called ether.
Didn't Einstein debunk the whole ether thing with his theory of relativity?
He did. That is a classical concept of a static ether.
Yeah.
However, the people arguing for a non-moving Earth in this video are suggesting that there's a different kind of ether, a fluid or a drifting ether, and this is something that actually wasn't considered back in Airy's time.
So they're saying that this alternative ether theory
Yeah.
could explain why the angle of aberration didn't change in his experiment.
Exactly.
Right.
They say that this ether drift
Right.
could be interacting with the light
Okay.
in such a way that it would cancel out the shift in angle.
That's a pretty bold claim. What about the other side of the debate? What do those defending the conventional view have to say about all this?
Well, in the video, there's actually a physicist named Franco
Okay.
who joins in and defends the mainstream scientific model.
Okay.
And he argues that the principle of relativity could explain why Airy didn't see the shift he was expecting.
Can you remind me how relativity works? It's been a while since I took a physics class.
Right. So in the most basic terms, the principle of relativity states that the laws of physics are the same
Okay.
for all observers that are in uniform motion. So in other words, whether you're standing still or moving at a constant speed in a straight line,
Right.
the physics should work out the same.
I think I remember that from school.
Okay, but how does that apply to Airy's failure?
So Franco is arguing that because the water in the telescope
Yeah.
is moving along with the Earth,
Uh-huh.
you can basically treat it as if it was at rest
Okay.
from the perspective of the light passing through it.
Okay.
And this, he claims,
Yeah.
is why Airy didn't need to tilt the telescope further, even though the Earth is moving.
Okay, so basically he's saying because the water and the telescope are moving together, you can ignore the Earth's motion altogether.
Mhm.
That seems a little too convenient, doesn't it?
And that's exactly what the people who support the ether theory bring up.
Okay.
They're like, wait a minute, if the Earth's motion is what causes this aberration in the first place,
Right.
then slowing down the light with water should still affect the angle.
Right,
They're
right.
saying, like, switching reference frames?
Yep. To the water. Doesn't just make the Earth's movement magically go away.
Right, right. No, that makes sense. I'm starting to see why this got so heated. It sounds like both sides have some good points.
Mm,
But if Airy himself was expecting the angle to change,
yeah.
isn't that a problem for Franco and the mainstream science people?
You've hit a really important point.
Okay.
The people in the video actually dig up a passage from Airy's book on the undulatory theory of light.
Okay.
And in it,
Mm-hmm.
Airy very clearly states
Right.
that the angle should change
Mm-hmm.
when light passes through water.
Wait, so the guy who designed the experiment literally wrote in his book that the result should be different
Exactly.
from what he actually observed. Oh, wow. Okay.
It's pretty mind-blowing, isn't it?
Yeah, that's wild.
Yeah.
What exactly did Airy say?
He lays out his mathematical reasoning.
Yeah.
He says, for if the tangent of the angle of aberration is the ratio of the velocity of the Earth to the velocity of light, then since a latter velocity in water is 3/4 of its velocity in a vacuum, the aberration observed with a water telescope should be 4/3 of its true value.
Okay, can you translate that for those of us who aren't, astrophysicists?
Sure.
Thanks.
He's basically saying that the angle should increase proportionally
Okay.
because the speed of light slows down in water.
Okay.
And the fact that he didn't observe this increase
Right.
is why it's a failure
Right.
in terms of supporting a moving Earth.
Wow. So even Airy himself acknowledged in his own writing that this experiment contradicted the theory of a moving Earth.
Yeah.
This is getting really interesting. What else did the people who were, disagreeing with the mainstream view have to say?
They really focus on the point that mainstream science doesn't really have a good explanation
Okay.
for this failure.
Okay.
They challenge Franco to provide some sort of mechanism within the current scientific model
Uh-huh.
that would explain why the experiment had these unexpected results.
So did he have a good answer for them? Was he able to explain it?
He tried,
Okay.
but his explanation seemed to kind of fall short.
Okay.
He kept coming back to this idea of different frames of reference
Yeah.
and how, from the perspective of the water,
Mm-hmm.
there's no horizontal motion to worry about.
Okay.
But of course, this just made the argument even more intense.
Yeah, because if the Earth is moving, shouldn't that still matter? It's like he's just trying to get rid of the Earth's movement just because it doesn't fit.
That's exactly what they said.
Okay.
They argued, if we accept that Earth's motion is the reason why we see aberration,
Uh-huh.
slowing down the light with water should still have a measurable impact
Okay. Right.
on the angle.
So it sounds like we're at kind of a standstill here.
Yeah.
The defenders of mainstream science are having a hard time making this experiment work
Right.
with their current understanding of stellar aberration. And the people supporting the ether theory are saying, hey, this helps our argument for a non-moving Earth. Sounds like a real tug of war.
It does.
That's it.
And that's where another intriguing participant enters the conversation.
Okay.
A YouTube host named Proud
Okay.
jumps in and throws out this challenge
Okay.
that gets right to the heart of this whole thing.
Okay. I'm all ears. What do you have to say?
He basically argues that if the Earth is really moving
Yeah.
at 66,000 miles per hour,
Mm-hmm.
like science claims,
Right.
then we should have to constantly be adjusting our telescopes
Right.
to account for this motion as we're looking at the stars.
Right.
And he used a really simple analogy to kind of illustrate his point.
Okay. I love analogies.
Yeah, so imagine you're trying to throw a basketball into a trash can
Mm-hmm.
that's moving sideways.
Okay.
If the trash can's moving, the ball's not going to land directly in the center.
No, it's
not
going to
gonna-
miss because the can's moving while the ball's falling.
Exactly.
Okay.
So Proud is using this to suggest that the starlight should also be hitting the Earth
Okay.
at a different point
Mm-hmm.
as it travels through the water in the telescope,
Okay.
and therefore the angle should change.
And because Airy's experiment didn't show any change in the angle, Proud's saying that means the Earth is stationary, right?
That's his argument.
Okay.
He directly challenged anyone to come up with an explanation for why the telescope didn't have to be tilted further
Right.
after they added the water if the Earth really is moving.
Wow, that's a good point. Okay, so did anyone take him up on that challenge?
Well, you'll have to wait till part 2 to find out
Ooh.
what happened next.
Okay, tuned.
All right, I'm hooked.
Franco did try to answer Proud's challenge,
Okay.
but his response kind of went back to that idea about reference frames.
Wait, reference frames again? Didn't the YouTubers already address that? Like they said, changing the reference frame doesn't just erase the fact that the Earth is moving?
Exactly. And Franco didn't really change his argument. He basically doubled down and said that if you shift your focus to the water in the telescope.
It's like the horizontal movement of the Earth disappears.
But how does that make sense? That's like saying because I'm sitting in a moving car, I can pretend the car's standing still.
Yeah.
The Earth is moving, right? You can't just ignore that no matter what reference frame you choose.
And the YouTubers kept pointing that out. They said it's like Franco's explanation means the water is creating this little bubble of reality where the Earth's motion is canceled out.
It sounds like he's using big science words to avoid actually answering the question. Did he offer any, evidence or calculations to back up his claims?
He mentioned something called a Galilean transformation,
Okay.
which he claimed could explain the change in reference frames. But he didn't really go into detail.
A Galilean transformation? That sounds like something out of Star Trek. What is that?
Basically, it's a way to compare measurements between two things that are moving at a steady speed relative to each other.
Oh, okay.
Like, it works for things we see every day, like cars or trains,
Mm-hmm.
but not really when you're talking about things moving at the speed of light.
So he's using a concept from old school physics to explain something involving the speed of light? Something seems off about that.
You got it. And the YouTubers were quick to point that out.
Mm-hmm.
They said, using a Galilean transformation here doesn't make sense
Okay.
because it doesn't account for relativity and all that craziness that happens when you're dealing with light.
So we've got these YouTubers talking about ether drift and Franco using reference frames and Galilean transformations. It's like a physics showdown. But they're talking about an experiment from forever ago. Is there any modern evidence to support either side?
That's a great question. And you're right, science is always changing. Airy's experiment did raise some big questions, but didn't prove anything for sure about a stationary Earth or the existence of ether.
So what's the current thinking about Airy's failure? Is there a good explanation that fits with what we know about physics?
Well, it's still being debated, but some physicists say that newer, more precise versions of Airy's experiment
Okay.
have shown the angle of aberration changing like it should,
Mm-hmm.
which supports the idea of a moving Earth.
But what about those tiny changes in the angle the YouTubers talked about? Didn't they say those could be evidence of ether drift?
They did. But mainstream science usually says those small differences
Yeah.
are just due to errors in the experiment or limits of the equipment. Remember, Airy did his experiment over 150 years ago. Technology has come a long way since then.
Right. But is it possible those errors are actually clues to something we don't get yet? Could there be something about reality that our current theories aren't catching?
Well, that's the exciting part about science. It's always about questioning, testing, and refining our understanding of how the universe works. Right now, most people lean towards the idea of a moving Earth and no ether. But the debate about Airy's failure keeps pushing scientists to think critically and explore all possibilities.
This deep dive has been amazing. It shows how even a simple experiment can shake up what we thought we knew about science. It makes you wonder what other mysteries are out there waiting to be discovered. But let's get back to Airy's failure. What happened next in that video? Did they wrap things up or did it get even crazier?
Well, believe it or not, there was another twist.
Ooh, I had a feeling. What happened?
Remember how Franco kept bringing up relativity to support his argument?
Yeah, he was really into that.
Well, the YouTubers found something that seemed to contradict that whole principle.
Okay, I'm on the edge of my seat. Tell me, what did they find?
They pointed out that in order to even see stellar aberration,
Uh-huh.
astronomers have to tilt their telescopes a bit.
Right, they have to adjust for that angles because the Earth is moving.
Exactly. And the YouTubers said that this tilting actually goes against Franco's whole argument about reference frames and relativity.
Wait, I don't get it. Can you explain that a little more?
They're basically saying if relativity is true,
Okay.
meaning the laws of physics work the same whether you're moving or not,
Yeah.
then it shouldn't matter if the Earth is moving or not. We
Yeah.
should still see the same angle of aberration either way.
So if Franco's right and we can just switch reference frames to make the Earth's motion irrelevant, why even bother tilting the telescope?
That's the big question. And Franco didn't really have a good answer. The YouTuber said the fact that we have to adjust our telescopes to see stellar aberration means that Earth's motion is important,
Right.
which goes against what Franco was saying.
Wow, that's smart. It's like they used his own logic against him. Did he have anything to say to that?
He tried to explain it away by saying tilting the telescope is just a practical thing,
Okay.
a way to make observations easier. He said even if the Earth wasn't moving, we'd still need to tilt the telescope to account for the angle of the starlight.
But wouldn't that angle be different if the Earth was stationary? It seems like he's really reaching here.
That's exactly what the YouTuber said. They argued if the Earth wasn't moving,
Mm-hmm.
we wouldn't need to adjust for stellar aberration at all. The starlight would hit the telescope directly, no tilting needed.
So it seems like Franco's losing this debate. Did he have any other arguments, or did the YouTubers win?
Well, you'll have to wait for the final part of our deep dive to find out.
Okay, so Franco's in a tough spot here.
Yeah.
He's trying to defend this idea of relativity,
Right.
but the YouTubers have kind of poked a hole in his logic by pointing out that telescopes need to be tilted to even see the stellar aberration thing.
Yeah.
Did he have any kind of comeback?
He tried to respond,
Okay.
but it seemed like he was having a really hard time
Mm-hmm.
explaining why we need to tilt telescopes.
Right.
If his whole point was that the Earth's movement doesn't matter.
Right.
He threw out a few more analogies and explanations,
Okay.
but the YouTubers weren't buying it.
So it sounds like the YouTubers basically won this debate. They challenged how we normally explain Airy's failure and made a pretty strong case for at least thinking about some different viewpoints.
Yeah, I think that's a good way to put it. They definitely showed that there are some things about Airy's failure that don't quite add up.
Okay.
And they even got Franco to admit that he needed to do some more research.
It's wild how this experiment from over 100 years ago
Yeah.
can still cause such a big debate.
It really shows you how science works.
Yeah.
It's all about asking questions, testing things out, and being open to new ideas, even if they sound crazy.
It's like science isn't about blindly believing everything you hear.
Yeah.
It's about always pushing the limits,
Exactly.
questioning things, and being open to new possibilities.
And who knows, maybe someday someone will come up with an experiment
Yeah.
that either proves what we currently think about Airy's failure
Okay.
or completely changes everything we thought we knew
Mhm.
about physics and the universe.
That's so cool. It's like science is one big adventure
Yeah,
with new discoveries always waiting to be made.
always.
But before we go, I'm still thinking about that ether drift idea.
Right.
Is there any way that could be a real thing in modern physics?
That's a great question. The old idea of ether as this stuff that just sits there in space
Yeah.
has been pretty much thrown out. But some physicists today are looking into new ideas about space-time
Yeah.
that could bring back the idea of ether in a new way.
Wow, so the ether might not be gone forever. It might just be waiting to come back in a different form.
That's a possibility. Some theories, like quantum gravity,
Mm-hmm.
suggest that space-time might be a lot more complicated than we realize.
Right.
And maybe this structure could act like what people used to think ether was.
So you're saying that ether, in some new form, could be part of how we understand the universe in the future? That's amazing.
It's definitely something to watch. As we get better tools and theories,
Yeah.
we might find new evidence that challenges what we think we know
Yeah.
and opens up whole new areas of science to explore.
This whole deep dive has been mind-blowing. It's a reminder that there's so much we don't know about the universe,
Yeah.
and what we think we know is always changing. So to everyone listening, stay curious, keep asking questions, and don't be afraid to challenge the norm. You never know what incredible discoveries might be just around the corner.
That's the best advice. The search for knowledge never ends, so enjoy the journey and never stop exploring the amazing universe we live in.